First of all, welcome everyone who has joined. So, welcome and thank you for registering and to be a part of this event. Essentially, we do have these lunch and learn sessions every week with some interesting topics. So, the last time I took lunch and learn session, we got into the basics of SQL, and we also covered parts around the kind of databases that we have. Then we also distinguish between analytics and transaction kind of databases. So that was in the previous session. Now this in this session we are going to look at exploratory data analysis. And thanks to Purple Beard, now we will have these sessions, I think, if I'm not wrong, every week and with various different topics. So who are we? We are Purple Beard, an edtech company, and we are on a mission to disrupt the tech sector with challenging, engaging, and highly selective learning experiences that are developed by industry experts. So most of our trainers who are working here also works full time as a data scientist or data engineer. So they bring in a lot of industry experience into the program as well. And there is an employability team who will be assisting you for your job searching while you are on the bootcamp as well. So our aim is to create employable tech talents and to bridge the diversity gap that we have in the tech sector. So yeah, that is who we are. And for the topic now, we are going to cover exploratory data analysis in Python. And I'm going to quickly jump to the notebook, so notebook is a platform which we use for doing our analysis. So there we can have some text cells wherein we can leverage some theory, or we can write some theory related to the concept that we are covering. So a notebook, you can understand it as a encapsulation of some text and some code, and all the combination of those makes a notebook. And of course you can have some visuals, some screenshots also you can attach on a notebook. So that way we can cover some theory around the concept, and as well as we can code in the code sets, respective code sets. So we'll be leveraging a, a cloud-based notebook that we have, and that is given by Google. So I'll be using Colab, which is a service given by Google. So what they do is, it is a free, all you need is a Google account to get started. You can upload your IPYNB files or the notebook files into that platform, and then you can directly open and start playing around start doing your analysis there. It will allocate some resources like RAM and ROM, as we say. So it will allocate around 12, if I'm not wrong, 12 to 13 gigs of RAM, and it'll give you around 107 gigs of storage or something around that. But that is enough resources for you to get started with. So we'll be using that platform. Now, before we jump into that, some preliminary safety. So your safety is paramount to us, and we aim to create a safe learning environment. And we also want to ensure that you're safe in the remote learning. So we have certain processes while in the environment. If you have any safeguarding concerns, there is a dedicated team to help you in that regard. But all in all, we want to also say that stay hydrated and maintain your focus on your mental health and well-being. So I am Kapil Parekh. I work as a data scientist currently at Purple Beard, and I also teach. So I'm also a data trainer here. The cohort that I'm currently taking will be my 7th cohort. So with that being said, let's jump on to our notebook, and let's explore the topic through a data set that we are going to use. This data set and the notebook will be provided to you guys as supplementary materials afterwards. But first of all, to reach where I am currently, you have to go to collab.research.google.com. So I was talking about this data set that we'll be working with. So this data set has a title column, a genre column, description, director, actors that were involved in these movies, the year in which this movie was released, the runtime of this movie, rating, votes. Now, votes, rating, metascore. So, metascore is basically a score given by 100, and um, from what I've read, they basically combine a lot of scores by some professional critics as well as some user-defined scores. But these scores, ratings, and metascores are basically telling us about how good or bad the movie is. And we'll be looking at these features as well and see if there is any relation to that with the revenue. So I've already started thinking about, I've already started talking about association of different features in a data set with revenue, or some target feature that I am interested in. So first of all, this is the data set that we'll be working towards, and I'll attach that, or we'll send it across as supplementary materials. The file that we, once we reach the end, all the visuals that I create, I'll be sending the entire notebook across as well, so you can have a look if you wish to. So the process that we are talking about currently is called as exploratory data analysis, and it is an essential step in the data analysis process. And it involves examining and summarizing the main characters of a data set. So basically, here you are trying to explore the data set and you are trying to make sense of it in one term. So if you look at this data set, this IMDb data set, it has a lot of data within it, but I still can't say a thing or two about this data set until and unless I know, or I play around with it, or in other words, I explore it. So the primary goal of EDA is to gain a better understanding of the data, then identify the patterns, relationship, anomalies, and insights that can inform further analysis. Now, typically, if you look at a typical scenario in an organization, now this might differ because currently the roles are also maturing. Previously, we had a lot of roles as data scientists. Now we have a lot of machine learning researcher, or the roles are being split now. I mean, that is what we have been observing. However, there are still data scientist roles, but again, as I said, the data roles in this domain is maturing because the tasks are quite interrelated. But if I were to generally tell you what happens, then there are three main players in a data company who is working in this data sector. So the players are the engineering team, the data engineering team, then there are data analysts, and there are data scientists. So engineering team is responsible for making sure that there is data in the services or in the databases or in the data warehouse for further analysis to be done. Now they make sure that the data is extracted from the relevant sources, and they make sure that the data is pre-processed into the schema or the structure which the data analyst would be able to use, or a data scientist would be able to further utilize. So they make sure that the data is ready, and that is the job of a data engineer. If I were to generally state their working, however, there are different work schedules, and it is very difficult to state it in 2, 3 sentences. However, that is the general rule. After that, data analysts, they do a lot of exploratory data analysis, and they do a lot of reporting. So with those reports, we understand a lot of we get a lot of actionable insights about the data. We understand the data more. Then comes the prediction part, or the predictive analysis part. Now that is taken care of by the data scientist. Even, I mean, there is some roles you may observe, even though the role is of a data analyst, you are still involved in a lot of predictive analysis, and that is still fine. But I'm saying that these are the general responsibilities. So while making the models, or while doing the feature engineering, the initial EDA process, the initial reporting of the data helps a lot to understand what sort of features should I add or remove. In other words, feature engineering, if I were to again overly generalize. So what features in my data set, or what columns in my data set is actually providing more information to reach, or to make my prediction better for predicting the target variable, or to predicting or to for the classifying of a target column, let's say. So that could be a task wherein you're predicting a value or you're predicting a class. So based on that, you can say that it is a regression problem or a classification problem. However, overall, that is a prediction problem. So with prediction a task. So with that said, we need to also make sure that the data that we have in hand is actually containing relevant information to actually improve my prediction. So that is where we decide as to which features are important. So if we talk in the context of this IMDb data set itself, so if I were to predict the revenue of a movie given other information, so I can say, like, I mean, I can get this director data. This is also important for me, because then I can say what is the average kind of revenue that the movie made when director was James Gunn. So again, this director as a column gives me that information. Like if I could associate that with previous data, I can draw or extract some information out of it. But if the for revenue column, if there is some other feature which does not have any relation to revenue, then I may as well just remove it from my data set, because it does not add any value to my prediction. So all of that could happen, but before that, we need to explore the data set. We need to understand what data lies within the data set. And I mean, what insights can we extract from it? And then we report it. That report we gets utilized by the team, by the data team, and then further we expand on it. So this is how, a general idea of how processes are there. So as we are talking about EDA, so key aspects of exploratory data analysis includes data summarization. So here we can do some sort of a summary statistics such as mean, median, simple stuff. So mean, median, standard deviation, quartiles to understand the central tendencies and variability in the data. So if I were to talk about this IMDb data set, I can talk about the runtime column with respect to these values, like what is the average runtime, what is the standard deviation of the runtime, then what is the minimum and maximum runtime. So that tells me a lot about this column and how the data is distributed within the column. So that is what you say as data summarization. Then of course, visually sometimes we can understand things better. So we data visualization plays a very important part here. Then we have data distribution. So if a data follows a certain distribution, let's say binomial distribution or normal distribution, so we have some solutions if the data follows that distribution. We know thing or two about those kind of distributions. So that's why we see if the data actually follows a normal distribution. We can do that by plotting a QQ plot and see if there is a straight line and stuff like that. There are various ways to do that. However, our idea is that if the column or a data or follows a certain distribution, then we know a thing or two about the probabilities or how to calculate the probabilities among a certain distribution. Let's say if a data follows a binomial distribution, there's a formula to calculate the probability if data follows binomial distribution. So we also check that. Now, examining the distribution of the data to understand shape and whether it follows a particular statistical distribution. Then we see if there is any outliers in my data set. Now, I mean, there are always outliers in data. Think about this, like let's say if we talk about the property prices of a particular region. Now, overall in a region, the property prices are at the same level in a particular region. Let's say, just imagine that general region. Now, in one place within that region, you might see that the property price is a lot. Maybe because that property is next to a landmark or a celebrity's place or something, or if the property is a celebrity is owned by a celebrity, or in that case there are some other reasons as to why the property price was higher, but that can we can treat it as an outlier in our whole sample that we have with regards to that region. So outlier detection also plays an important role, like identifying data points that significantly deviate from the norm, which can be errors or provide valuable insights. So sometimes it could be errors, outliers could be errors as well. But sometimes it can provide some valuable insights as how I stated with an example of property prices. So property price is higher. It may be the case that it is not the area which is governing the price, but it is some additional factors like is it owned by a celebrity or is it somebody else? Or is it because next to the property there is some important institution or something like that, right? It could drive the property price. So there are some additional details that we might need to explore. So outliers could be because of an error, or it could provide some valuable insights. Now, data relationship, analyzing how variables in a data set relate to each other. That could be one thing to find out, like how we, when I was talking about this data, first point that I made was, is rating related to revenue column? So that is like quite obvious. One might think if the movie is highly rated, it might do well in cinema or in the box office. So that a relationship kind of we also explore. However, there is some missing data. So we handle that data as well. We'll see in this data set that I'll be looking at. We have some missing data within it. Then we'll do some transformation. Also, that part we'll be exploring. Like for example, this one. In the data, I mean, think about this as an Excel file, right? In the Excel file, you have a genre column. In that, you have action, adventure, sci-fi. So there are multiple genres. Over here, you just have two for this movie split. So how can I, just calculate how many movies come under action genre? So I have to do some sort of a transformation to this data, right? Because how will I calculate then, like how many for action and how many for adventure? I may make like individual columns to store each, like because I know a movie is a combination of three genre in my data set at max because of, well, like given the data that I have currently. So what I can do is I can, split and expand and make it like three columns. Each of that column could have a value, and then I mean, I can do some transformation, like how I have done over here. Like, could split it and I could stack it such that, like, see, this is how I would do it. So, like, I would split the column, then what I would do is I would stack it. So when I stack it, then the number of rows that you have currently is 872. It will be increased drastically. So the idea is that we give each row like the same row for each movie, action and likewise. So now I can calculate the value or the number of times each genre was there in my data set like this. And then I can get like, okay, 440 movies out of the whole movies were under drama category, and action were around 286. So I mean, we needed to do some sort of a transformation. So we do that as well as a part of EDA. Then pattern recognition, yeah, we recognize pattern, and the finally data exploration. But yeah, these are the key aspects of what is included in an EDA process. So EDA is typically performed by data scientists, data analysts, or domain experts who have an understanding of the data and the context in which it was collected. So it serves as a foundation for subsequent data analysis. See, it serves as a foundation. This line is very important because EDA is the first step. After that, it serves as a foundation for what you need to do next. It could be for, for the data analysis or for modeling, deciding how you should model our data. Or I could give you more examples on why EDA could help in modeling, but if time passes, I'll explain that as well. Then we can directly use the insights that we found while exploring the data sets in decision making process. So as you can see, like there is no there is no strict guideline as to what happens, but there is a general guideline, if you will. So if you were to do a data analysis project, and this is what I also send it across to my students, that this is what typically is involved in a data analysis project, and this is what you have to do to make or upload a project on your GitHub, so as to get some recognition from the employers when you are searching for a job. So first step would be to first and foremost, you have to start with the problem statement. So here is where you define a problem, right? And then you'll collect and clean the data which you think would associate with the problem, or you think would provide me some answers. Now then I can explore and see if it is actually valuable, and then I could prune the data that I have. Let's say I started off with 1,000 things, and then I have 10 things which are actually useful for me. But the first step would be to collect the data and then to make the data usable by cleaning the data. The data might have some error, so we might need to clean that as well. Then you perform EDA, then you can do some statistical analysis as a part of EDA as well, but it depends on if you have to do that or not. Then and sometimes the data that you have at hand is not the entire data. It may be a sample out of a population. So that's when actually you need to do some hypothesis testing and stuff like that to actually see the conclusions that you or the it won't be conclusion. You would just be able to hypothesize with the sample, and then you'll have to see if it actually relates with the population. So then we draw a conclusion, and then we document the process, and we can share it on GitHub. So I think let's get started then with the data that we are going to look at, which is IMDb dataset. And so before I get started, the first thing is that you do not have to worry a lot about how code is written. The idea of today's session is not that at all, because we are when the bootcamp starts, we do start from scratch. So we start by Python, then advanced Python, NumPy, pandas. Likewise, we go. So this is where this is like when we are done with pandas, and then we are done with visualization modules. That's when the students will be able to do this. However, since there are a lot of visuals involved, you'll still be able to relate with the concepts taught over here. So what I'm going to do first is I'm going to import some necessary modules. So necessary modules are, these are the kind of, you can think of it as functions of some code which you didn't write, but you are leveraging some third party code or, the correct word to use is module here. So these are third-party modules. These are not, they do not come pre-installed with Python. You have to install it. So there are different use cases of this, like pandas is involved for handling data, which is like a two-dimensional Excel kind of a thing. I mean, it can handle a lot of other things as well, but it is typically used for a table-like structure. So, and then NumPy is used for numerical computations a lot. And then Seaborn is a library used for visualization. Matplotlib is also a library used for visualization. So think of Matplotlib, it will give you a base structure, and Seaborn will just beautify it. Then what I'm going to do is I'm going to open the data set that I have uploaded over here, IMDb dataset. This is a typical CSV file that you'll get. I got it from Kaggle. Happy to link it afterwards as well. But you can go to Kaggle and search for any data set that you want. I think my first search here was IMDb. So here you'll find a lot of IMDb movie dataset because I mean the dataset that I have contains 1,000 movies, but you may find some like dataset which has around 50,000 or 10,000, those kind of movies as well. I started off with this. So the first thing first, I'm gonna read the Excel file and I'm gonna store it in this variable, and then I'm gonna look at the 5 rows in this. So that's fine. Okay, let's get used to the schema, or let's get used to the structure of this document. So I have the rank column, which is basically just a number given to each movie. That's fine. Then there's a title column, which is the title of the movie. Then there is the genre column, which is the genre of that movie. But as you can see, the data that I have is comma separated within the column. So I'll have to do something to that. Then I have description. It is just a description given for each movie. I'm gonna not touch this at the moment because we're gonna have to leverage a lot of other modules to deal with this kind of data. It is basically natural language processing because this is, I mean, it does not come under a category. I'll have to use different kind of techniques to draw insights from this kind of data, like this kind of texts, which may come from an open-ended questionnaire as well. And but this is just a description written in natural language for this movie. Then I'm going to look at director column, the director of this movie. Then we have a lot of actors for each movie. The runtime of that movie, this is in minutes. The year in which this movie was released, rating, and votes, revenues, and Metascore. All right, so this is the data that I have. I'm just looking at 4 rows. However, there are a lot of rows. So if you want, you can just write data, and then you'll have all of these 1,000 rows. So these is the kind of data. These are the kind of movies that I'm gonna look at. Now, first things first is I want to check how many rows are null. So, I mean, how many cells contains empty value. So if I do is null, it gives me a Boolean value for each cell if it is empty or not. So if it is false, that means some data is stored in there. But I mean, this is usable for me. So this tells me that for revenue column, we have around 128 data, which is missing. For Metascore, we have around 64 data, which is missing. If you want to visually look at it, I'm going to use a heat map given by Seaborn. And I'm going to visualize this output, which was a Boolean output over here. Like this, this exact table, I'm going to look at it in a visual form. So how does that work? It basically assigns a color for false and it assigns a color for true. So it just works because there are only 2 possible values in this. So that's why it just uses 2 typical colors. But yeah, you can plot it, SNS heat map. So when you plot it, you will see this visual. Now, what does this mean? Wherever you see this kind of yellowish, or I would say whitish lines, these lines represents rows. These are rows. This is from 0 to 975 kind of rows. Now, these are the lines where the data is missing currently. So this row, in this column, revenue and Metascore, the data is missing. So wherever you see patches, these are the missing values in the data. Now, there are multiple ways in which you can deal with this kind of data. Like I would say revenue column, because revenue column depends on the lot of factors. So I can't just merely take an average of that column and then place it with missing values. That would be wrong, because if I take the average of all the movies and I place that value, average revenue, it would drastically differ from the actual value. So the wise thing to do in this case, rather than there are various ways to deal with this. Like I could make it a linear regression problem, then I could predict this revenue figures from other values. I could do that. However, for starters, what I'm going to do is I'm going to drop these values wherever revenue column is missing. Then what I'm going to do is that leaves me with some columns which are that leaves me with some rows in Metascore column which got deleted because that value and the revenue column was also missing. So, but I'll still be having some. If I check it again, I'll still be having some missing values. So I have around 34 missing values for the Metascore column now. Previously, there were around 64 or something when we last saw. The data that we have currently or we are playing with currently has some missing values within it. So to deal with that missing values, what I did was this is after it is dealt with. So for the revenue column which was missing, I removed those rows, and Metascore column which had some missing values, I took an average of Metascore column and then put that value wherever the values are missing. So that's what I did so far. Nothing extra. So this is the data that I have currently, but it does not have any missing values at the moment. So if we look at data.decimal.sum, wouldn't have any missing values over here. So that's fine. Now, what I want to do is, the idea that came in my mind was that if are there any association with the revenue with other numerical columns and the revenue columns. So let's look at that actually. So I have this data set, and the numerical columns that I have over here are what? I have this rating column, then I have votes, I have revenue in millions, so on. Then what else do I have? I have Metascore, then I have runtime. I think it's minutes. All right. So if I take correlation of each value with each other, votes is not an index. So what is the name? Columns. Oh, B is capital. Right. Okay. So I have some correlation numbers with the permutation of these groups that we can make. We are interested in the revenue bit. So revenue with rating is 0.21. So think about this like this. If the number that you see over here is closer to 1, that means it is also like it shows a perfect positive correlation. So one example would be revenue with revenue. So when revenue increases, revenue also increases. But I mean, this is because when you take pairs of these permutations of these columns, you will find one pair which is basically the same column, like revenue. So all of these values that you see in the diagonal are ones. And then you want to actually see the values which are greater than 0, obviously, but it should be closer to 1 for it to be positively correlated, or for it to show strong positive correlation. So this, by looking at numbers, it works. However, I might store it in correlation variable, and I would want to plot it and see the visual side of it. So because then I can understand data better. So let's plot it. Give it a fixed size of 10, 7. So with 10, height 7. Again, I'm gonna use heat map, and it's gonna take correlations. Then some arguments I'll set to it. Then the color that I want to use with it. Also, I've provided a color palette over here. So for some visuals, we'll be looking at some of these color palettes as well for some visuals. So I'll be using those names as well. But color map is cool warm. So it will use a sort of red, orangish kind of color. And this, and I'll give it a title. And yeah, I can just show it now. Execute. All right. So now visually you can understand which columns show some positive correlation. So like, I mean, this bottom left of the diagonal, like bottom left this side, and upper right, either of them you can look at, because it will obviously be symmetrical in nature. So let's look at this patch, and this patch. So we can see Metascore and rating show a positive correlation, because of course rating is like user rating, Metascore is a combination of user rating and some other critics and stuff like that, but it shows a positive correlation. I'm interested in revenue though. So revenue with respect to, let's say this is the revenue with respect to votes. So if you have high votes, we will have higher revenue, and it shows a correlation of 0.64. Of course, it shows um for Metascore. Let's see. Yeah, 0.14. All right. So Metascore does not translate well with revenue. Good to know that votes play well. So the user votes, the end users or the audience votes matters with revenue, and not the synthetic score which is generated. But yeah, these are the kind of initial insights that I can find with a correlation kind of this thing. But now I want to see, like, are the ratings in my data, like what sort of a distribution does it follow my rating column? And I want to see if there is, a tendency for the users to give like a rating less than the midpoint, or I would say like not a negative rating, but if you say the ratings are given out of 10, then I want to see if the users tend to give rating which is less than 5 or greater than 5, just to see what side it is skewed towards. Then what I can do is I can make a kind of a histogram plot for the rating column. So that I can do. So I'm going to use Seaborn, and I'm going to set a style to it. All right. So set this style. And again, we'll have to start off with a figure. So I'll give it a figure, and then fixed size I can supply, which would have the width of 10 and this of 6. That's it. Then I'm going to use SNS hist plot. Now, dealing with these kind of different plots and stuff, oh, I haven't supplied an argument to it. So sometimes it is very common for us programmers to, sometimes forget the arguments which are available. So for that, looking at the documentation is very important. And also overall understanding how to read the documentation is important. So I just open the documentation by this symbol. And then I can see for this visual, it takes these many arguments. So we have a data argument, like if you want to supply the entire data, otherwise X and Y you can supply. This U will control the, I mean, U is, how do I define it? It's more on a visual side. And then the bins, this will denote like how many bins you will observe in the histogram. If you write like 2, then you'll have like 2 bars only. Then bin width, all of these factors, it relates with different components of the visual. So what I'm going to use is I'm going to use data, and I'm going to use X. X will be nothing but it will supply the column from this data that you want to supply for the X axis. And yeah, I'll just use that for this histogram plot. And maybe I can use something else, like, because this will be a histogram, but what if I want to draw a fine line on top of this, and then I can use this KD argument as well. So let's use some of this and plot a histogram. So again, we should not forget, the point is not to learn how to code here, but like to see how data analysis is done and how we can leverage Python and different modules within it to explore the data at hand. And then let's say these are the arguments that I figured that I'll use. Bins, how many I should put. Say rating is out of 10. Let's put around 30 bins. And I'll give it a title. I'll give it a label on the x-axis. We put X on rating on the x-axis, so let's put that, and then some Y label as well. Would be the, this would be the number of movies, because this will take individual rating and how many users rated, it gave rating between 3 to 5, or because I have 30 bins, so it is like dividing this into into 30. So you will find basically what is the average rating between 1.0 to 1.5 or something like that, so that it makes 30 bins. But when we plot it, you'll understand it better. So let's say plot it now. All right. So this is the kind of plot that I see. And I can see the highest amount of rating that you saw was 7. So 7 as a rating was given in the maximum number of movies, that are more than 100. as you can see on this visual. And it is slightly skewed to the right hand side as well. So that is what we can understand from this data, that the distribution of movie rating and via the KD as well, it is slightly skewed to the right. KD is nothing but a smoothened plot using this histogram that we see over here. It is the full form of it is kernel density estimation, and we can see that most of the movies are rated between 6 to around 8 or something. So that is an observation that we found on this. Now let's talk about the point at hand, like which directors gave the highest revenue generating movie. I think let's do that. So what I'm gonna do is I'm gonna group, because there are multiple directors. I mean, let's say out of these 1,000 movies or 872 movies that you have in this data, these are revolving with around 30-40 directors, right? So each director would have like 10 to 15 rows in this data set. So what I'm gonna do is I'm gonna group by this, the director column. Then I'm gonna take this revenue column and I'm gonna calculate the sum of it. So it gives me the sum of revenue in millions for each director. But as you can see, it is not sorted. So I'll have to sort it as well. So sort values. And because I want to know which director had the highest revenue. So I want to sort it in descending order. So for that, I'll just put the ascending argument to false. And then let's look at top 10 directors. So we have J.J. Abrams, this 1,683 millions. So this is the figure that I have currently. So what I'm going to do is, let's say this is just 5. Let's take 10. Save this output in top directors. Yes. And let's plot it. So again, I'm going to start with the figure fixed size equals to 10.7. Now I'm going to plot a bar plot over here. And let's do, because this index is the director name, so top director dot index on the y-axis, and on the x-axis I want the revenue made, so for this the value of this. So I'm going to take values. It's equals to top directors, and let's use a palette. So this you can supply a color palette on this. So I'm going to use, let's use the first one. It is VIRIDIS. That's what you call that palette, but yeah, I just have to supply that argument. Yeah, right. And again, I'm gonna give it title. Say top 10 directors, and then some labels, X label. Let's say total revenue made by that particular director, and then Y label would be director. Then we'll pick up show. Let's see what we get. Okay. So visually, it is easier to compare. The kind of Christopher Nolan is third in terms of total revenue. Maybe because the other directors made more movies than Christopher Nolan. That could also be the case. So that's why we didn't take. I mean, if we took average, and it would just impact, because there might be some director who created it just created one movie, but it had a lot of revenue. So that might not say, that might not be a clear representation of top 10 directors. So I took some instead of average. Because let's say if a director made one movie and it made a lot of revenue. So when taking an average of all of these director movies, then we'll have to consider all of the movies made by this director. But for that particular director, we'll have to only take one movie. because he or she would have made only one. So that's why mean I haven't used, I've used sum. So to calculate total revenue made by the movies that these directors made. Now I think finally I would need to, I mean, I would like to plot, um, I would like to use this date, this year column that I have in this data, this year column. I want to see how many movies are made in each year, but let's plot this and then proceed. So what I'm going to do is simply, I'm going to take each year and calculate the number of movies wherein you observe 2016 in that row, because that will tell me how many movies were made in that year. So just to understand it properly, what I'm doing over here is, this is the data 2014, 2012, 2016, 16. So I'm calculating how many movies in 2016, how many movies in 2012. Every year I'm taking. So if you take the year column, these are the unique years in my data, right? So these are the unique years. I want to see how many for 2000, how many rows for 2014, how many for 2012. So there is a simple way to do it, but directly doing value counts is this is a method in pandas series that you can calculate the value counts like this. So it just counts the number of occurrence of 2016 in the data set. So it is 205 as you see. Then we can sort the index, because I want to, when I plot it, I want on the x-axis, I would want from 2016 until whatever the highest is, I think 2006 to 2016, basically. So I'll sort it and then let's plot it. So let's reuse. This is the only thing I can reuse. And X label, Y label as well, I'll reuse. So on the x-axis, I should have here. And this time I'm going to plot a line plot. And y-axis, I can have number of movies. And I have, let's say, SMS has line plot. Line plot, yeah. Right. So we have X value as, I have to save this though. Let's say M, just for now. So I'm going to do M dot index, then Y equal to M dot values. And let's put a marker as well so that we can see where the points are. So I'll use like a circle marker, and let's give it a title. Then I can do plt.show. Oh yeah. Okay. So this is on a visual perspective, you can see the number of movies drastically increased after 2015. 2015 you had this. In 2016 you had a lot of movies, at least. So yeah, I think this with these, I mean, we didn't get a chance to look at a lot of visuals in this 1 hour, but I think with this, you get an idea as to how we explore the data and then we find insights from it. So I hope you guys understood some aspects around how I was exploring things and what was my motivation behind even plotting one plot that you, or all the plots that you have seen over here. And I hope this made sense and you enjoyed the session.